Hi and welcome to E-ZTutoring. Today we are going to cover all the different rules for simplifying exponents. There are lots of them and I'm hoping to cover all of them in this one video. So starting off with the first rule, I will write my rules up top and I will do my examples down below. So if we have x times x, this one is to a power of a and this one is to a power of b, then you get x to the power of a plus b. Now, there's something very important to note about this. You must have the same base. You must have an x and an x. That is the only way you can combine them together to get just one x. Okay? So, a good example of this, say we have 2 to the square root of 7 times 2 to the square root of 7. So we have the same base, they are both 2's, so we can combine them to get just one 2, and then we take the exponents, and this rule tells us that we just have to add them. We just have to add a and b, so we add square root of 7 and square root of 7. Square root of 7 plus square root of 7. Now, adding square root of 7 with square root of 7 simply gives you 2 square root of 7. So that's our example. Now on to the next rule. Say you have x to the power of a, and all of this is to the power of b. What you do when you have a power on a power is you simply multiply them. So this simply becomes x to the power of ab. So an example of this, say we have a to the power of pi, and all of this is to the power of 4. Well, once again, you simply multiply your exponents together, and you get a to the 4 pi. Okay, another example here. Say you have x to the a and you're dividing this by y to the a. Now you notice over here we have different bases. We have an x and a y. So whenever you have different bases, you usually can't really combine them. You can't divide them. But there is something they share in common, and that is the powers. They both have a power of a. That means that you can take out this power and you can have x over y and put this whole thing to a power of a. This rule also works in reverse. So if you have x over y all to the power of a, then you can distribute a to each one and get this. So it works both ways. Now a good example, let's say we have 81 to the square root of 2 divided by 3 to the square root of 2. We can take out the square root of 2 and put it on the outside. And now here's why this rule is so good and why it's so important. Because now we can combine 81 and 3. We can divide them. And we will get 27. Now, you couldn't do this before because they had the exponents on them. So now that we divided 81 and 3, really by following the rules of PEMDAS, now we just put 27 to a power of 2. And look how much simpler this becomes. So these are the rules so far. Let me go ahead and split up the board in half here. Now we'll do the same thing on the bottom half. So, similar to this one, let's say we have x to the a divided by the same base x, but a different exponent b. This is equal to x to the power of a minus b. So a good way to memorize this is you multiply bases with the same exponents and you add them. But if you divide, then you must subtract. So those two always go hand in hand in mathematics. Now, a good example of this, let's say we have 3 to the 5 divided by 3 squared. Well, it's the same base, right? Different exponents, so we keep that same base. But now we simply subtract the exponents, so we do 5 minus 2. So this is simply 3 to the 3. Now, 3 to the 3 is 27, and you can find your answer to this much easier using this rule rather than actually doing 3 to the 5th and dividing that by 3 squared. Anyways, on to the next example. Let's say we have a negative exponent. So let's say we have x to the negative 1. This rule is very important and it comes up a lot in math. This is equal to 1 over x to the positive 1. Whenever you flip a negative exponent, it goes from negative to positive, or it goes from positive to negative. So a simple example of this, say you have 5 to the negative 1. This is equal to, well, you just flip it, right? Flip it and turn the exponent positive. This is equal to 1 over 5 to the 1. Say you have 1 over 9 to the negative 1. Well, once again, you flip 1 over 9, which gives you 9 over 1. And now, negative 1 turns into positive 1. And you can get rid of these two 1s, and this is simply 9. Okay, next example. Any number to the power of 0 is 1. So give me any number. Give me any number you'd like. You can give me 1 million to the power of 0. It'll be equal to 1. You can give me e to the power of 0, that's equal to 1. You can give me pi to the power of 0, that's equal to 1. So, last but not least, square roots. Scary, scary square roots. Say you have x to the power of a fraction. Whenever your power is a fraction, you know it is talking about square roots. So say it's to the power of a over b. I'm sure you guys have seen the little number inside the square root, where it's like a square root, a cube root, a fourth root, a fifth root. Anyways, that's what this b is. So this is b, the bth root, I guess you would say, of x to the power of a. So this is also really important, and a good way to memorize it is a is in the numerator. So a is the power of x, and a will remain the power of x, whereas the denominator, the fraction, is what root it is. So let's do an example here. Let's say we have 2 to the power of 3, we'll say 3/2. This is equal to the second root, so we're taking this 2 right here, the second root of 2, keep the base, to the power of a, right, to the power of a, which is this number, 3. 2 to the power of 3 is 8. So this is really the square root of 8. And this 2 right here, well, any square root that you see, any normal square root has a 2 in there, but they never label it because the 2 is standard. If you have a 3, however, or a 4, then those have to be labeled. But the 2 doesn't have to be labeled because the 2 is a normal square root. So these are all the rules of exponents, and going from Algebra 2 forward, it is very important to know all these, especially in your later classes. It's good to know these by heart. So I hope I helped you guys out. Be sure to check out my website, www.E-ZTutoring.com, for SAT and ACT help. Thank you guys, and good luck.